Hello everyone, this is Zhehua. You can call me David. Today we talk about the fundamental cloud security concepts. Here is the outline. First, we will briefly introduce the cloud computing and their deployment models. We will then introduce attack vectors in different cloud service models and their solutions. After that, we will highlight the best practices of cloud security. We then do a case study of the cloud security breach and talk about the future trends. We'll do a summary in the end. Okay, let's start. Let's begin with an overview of what cloud computing is and why it matters in today's information technology. Cloud computing has been defined in multiple textbooks, but roughly in a similar way. It transformed how businesses and individuals using technologies by providing on-demand service over the internet. These services including the storage, processing power, and the software applications, or accessible remotely. Some key features in cloud computing include on-demand self-service, and these services can be accessed by the broad network access, and it's based on the resource pooling. So the cloud service providers can combine those resources and provide it to you. It's a managed service. And for example, services like the Google Drive or Amazon Web Service allow you to access powerful tools without owning the underlying hardware. So take the startup as example. Imagine a startup using the AWS to launch an e-commerce site. Without cloud computing, they would need to invest in the physical servers, cooling systems, and maintain an IT team. Instead, AWS let them scale up or down instantly, and paying only for what they use. Security is critical for cloud computing because a lot of amount of those sensitive data actually stored and processed in the cloud environments. So let's first examine the deployment models. We have three of them. We have the public cloud, private cloud, and also the hybrid cloud. The public cloud is hosted by a third-party providers like the AWS, Google Cloud, or Microsoft Azure. We have the second one called the private cloud. So it's a private cloud because it's dedicated to a single organization. It offers a higher control, better privacy, and customization. But it comes with a higher cost for sure. For example, a bank may use private cloud to store sensitive customer information securely. In the middle, as you can see, we have something called a hybrid cloud, which combines the public and private cloud models, offering flexibility and scalability services. Then that we can talk about more about security. With the underlying of the deployment types, now that we can compare their security vulnerabilities to identify where the risk may exist. For the public cloud, it's rely on the shared infrastructure, so which make them more susceptible to data breaches and insider threats. For instance, unauthorized access to shared environment can compromise sensitive information. So the private cloud, while offering the greater control, often face risks such as misconfigurations or insider misuse. Additionally, organizations may over-provision resources, leading to inefficient use of the environment. And hybrid cloud, as you can see, it combines the features in the public and private cloud, so it may introduce the interrogation risks. It also may introduce the inconsistent security policies. And then it may cause the data leakage when you transfer the data from the private part to the public part. Moving forward, let's discuss how attackers target the different cloud service models. We also have the three cloud service models. First one is called software as a service, or SaaS. Second one is called platform as a service, and also the last one is infrastructure as a service. For the software as a service, the primary vulnerabilities are from its user-centric nature. Attackers often exploit weak password, phishing attacks, or shared credentials to get access to sensitive data. For example, an employee clicking on a phishing email link could compromise login credentials. allowing attackers to access internal email chains, financial documents, or other shared resources. For the Platform as a Service, or PaaS, vulnerabilities often arise from the insecure APIs or poorly written applications. Attackers might inject malicious code or exploit API endpoints to compromise the service. For instance, an e-commerce platform built on the PaaS solution could expose customers' data if its payment API is not properly secured. Attackers could also manipulate the system to perform unauthorized actions, such as executing scripts to exfiltrate sensitive information. For the IaaS, infrastructure as a service, misconfiguration of the virtual machine or cloud storage instance are common attack vectors. For example, the organization may unintentionally leave cloud storage bucket open to the public, allowing an unauthorized user to download confidential data. So first, we have mentioned the phishing data breaches and insider threat in the SaaS. For example, in the 2020, a popular SaaS email service suffered a phishing attack that compromises over 100,000 accounts. Attackers send fraudulent emails designed to look like legitimate password reset requests, tricking users into divulging their credentials. Deloitte did an investigation, and here is the link. It shows that more than 91% of all cyber attacks begin with a phishing email. To address this threat, organizations must implement robust security controls, like a multi-factor authentication to prevent unauthorized access, encryption for both data at rest and in transit, ensuring sensitive information is protected. Regularly monitoring and auditing access logs can help identify and mitigate risk proactively. For the Platform as a Service, we have introduced attack vectors including application vulnerabilities, malware injection, and poor API security. So the PaaS environments often face vulnerabilities in applications and APIs. For instance, in 2021, okay, so here's a link. Attackers exploit the API vulnerability to get access to sensitive user data in the popular payment gateway. To counteract these threats, developers must follow security coding practices and conduct regular vulnerability scans. Using API gateway with rate limiting and monitoring can significantly reduce risks. Next, let's examine the infrastructure as a service. The IaaS provides virtualized resources, but it also has its challenges. Misconfigured cloud instances are a common attack vector, leading to data exposure. For example, in 2021, okay, here's the link. In 2021, a misconfigured cloud storage bucket on the Microsoft Azure exposed 38 million records from dozens of organizations. Usually, when the vulnerability exists in the IaaS model, it affects not only a single application, but many of them will be the victims. For example, in 2022, the Microsoft Azure blob storage exposed the data of 65K companies and 548K users. So you can see how severe it is. Solutions may include network segmentation, deploying intrusion detection and prevention system, and also ensuring the encryption of the data alongside security key management practices. These steps would have prevented unauthorized access to the exposed data in the cloud storage bucket. So to conclude this part, let's dive deeper into the general best practices that apply across all cloud environments and understand why they are so critical. First one is MFA, multi-factor authentication. The MFA helps prevent unauthorized login, even if passwords are compromised. Second one is regular security assessment. Proactive assessment like penetration testing can uncover vulnerabilities before attackers exploit them. Third one is ensure compliance with industry standards. Okay, some famous standards including the ISO 27001 and the GDPR is usually referred as the General Data Protection Regulation. They are very essential for both legal compliance and customer trust. Employee training is so important because human error remains a major cause of breaches. And then we want to apply the collaborative with the cloud providers for shared responsibilities and security. So under this shared responsibility model, working closely with the provider ensure that infrastructure layer is secure. So let's just dive into each of them with more detail. Because the shared responsibility model is so important, I put it first. So building on the best practice, let's explore this model. We have the obligations exist on both this service provider side and also the customer side. On the provider side, responsibilities include maintaining the physical security of the data center, including surveillance and access control, ensuring the uptime and availability through the redundancy and the robust disaster recovery mechanism, also very last regularly updating and patching the cloud platform. The responsibility for the customer include the configuring access control and then permissions to prevent unauthorized access. Okay, and also encrypting the sensitive data before uploading it to the cloud. Last, okay, monitoring logs for unusual or malicious behavior. The key takeaways here is that understanding the shared responsibility model is essential to avoid this security gap. Because when we have the gap, the attacker can utilize the gap to do the exploits. Okay, so it's so important. Next one is regulatory compliance play a pivotal role in the cloud security, as we have the multiple very famous standards here. Okay, GDPR, as we have mentioned, is a general data protection regulation. It's to protect the personal data of the EU citizen. HIPAA represents the Health Insurance Portability and Accountability Act. Okay, its a health record must be encrypted before uploading to the cloud. PCI DSS means the Payment Card Industry Data Security Standard. It requires the retailer processing the payment in the cloud must implement strict access control and encryption. We have the challenges in this domain like data sovereignty, ensuring that data is stored and processed within jurisdiction that comply with the local laws. For example, Australian business using the cloud computing must ensure the data stay within the Australian border. And also the shared compliance responsibility, like this shared responsibility between the service provider and the customer, but it says that what the compliance should follow for both the service provider and the user. Okay, and then here is the highlights. Okay, the strategies for success. You need to choose the right providers as satisfy the regulation, and also you will do the regular audits on both the service provider side and the customer side. In the very last, you will do the employee training because the human factor is so important in security of the cloud. Next is identity and access management, IAM. Okay, so we have the three important components in the IAM. First one is the authentication. Second is authorization. Third one is lifecycle management. You should know that the authentication is the prerequisite for the effective authorization. By the authentication, and we'll identify who the user, okay, by using the password, biometric, or the multi-factor authentication. Authorization is defined that what resources the user can access or acting when and what they can perform with the resources. Or we can use the role-based access control to do so. Okay, and the user lifecycle management handles the entire life cycle of the access as employees joins or leaves the system, reducing the insider threat. The key takeaways here is that we want to apply the best practices for the first one, principle of least privilege. Okay, restricting user to the minimum access they need to perform their duties. Second, regular access audits. Periodically renew these permissions to identify outdated or the unnecessary access right. For the single sign-on SSO, simplified access by allowing user to log in once to access multiple services, enhancing both security and convenience. Next one is encryption. Encryption is a critical component of the cloud security. We have the two folds in the encryption. One is called encryption at rest. Okay, protects the stored data using algorithms like the AES-255, or we have another one for the encryption. It means that the encryption in transit. We're going to use this transport layer security for the data transmission. Okay, and then the cost encryption based on the keys. So the best practices for the key measurement include secure key storage. Usually we need to put the key in the dedicated hardware, and the key rotation, regular updating the key, minimizing this impact of the compromised keys, also the access control. Only authorized personnel should have access to encryption keys, reducing the risk of insider threat. So in a nutshell, we should know that okay, encryption serves as the last line of defense against data breaches. So it's so important. Very last one is called the threat detection and the incident response. So for the threat detection, we need to use the continuous monitoring. And for the tools, we can either use security information event monitoring, the measurement tools, or we can use the cloud native monitoring solutions, including like the AWS GuardDuty or the Azure Security Center. And we have the 4 steps when we have the instance. Okay, at the very beginning, it's based on the preparation. Okay, we need to deploy and regular update an instance response plan. Secondly, we need to do the detection and analyze using monitoring tools to identify and assess the scope of the threat. Third one is very important. It's called the containment. Okay, isolate affected system to prevent future damage. A common strategy is to disable the compromised account or restrict the network access temporarily. Last one is the eradication and recovery. Remove the threat and then restore the system to normal operation. This may involve patching, rolling back, or reconfiguring the system. So, and here is the highlights. We need to think about incident response is effective with proactive measures and employee training and then continuous monitoring for sure. And also an incident response plan should include containment, mitigation, and recovery. And now let's examine a real case. Okay, so in 2019, Capital One suffered a significant security breach due to a misconfigured web application firewall. So how it happens? It's caused by this misconfiguration allow attacker to use the server-side request forgery attack, bypassing the security control. And then this vulnerability undetected for months, which amplifying this impact. Okay, and data exposed, you can see as approximately 1,400 thousand social security numbers and up to 1 million Canadian social insurance numbers and 80,000 linked bank accounts. They are just breached. And the result is very severe. Capital One faced regulatory fine amounting to this 80 million and has to spend over 300 million on response and then remediation efforts. Okay, and then it's also damaged this customer trust for sure and lead to multiple lawsuits. On the positive side, however, the incidents prompted improvement in the cloud security practices, including stricter configuration audits and enhanced monitoring system. This case highlights that critical need for proactive security measuring, okay, such as regular audits, proper configuration management, and then robust threat detection system. In the future, so we have this AI and machine learning. Okay, so AI and machine learning enhance threat detection by identifying patterns of abnormal behavior, or we can apply the zero trust principle that require continuous validation, implementing a never trust, always verify approach for security. Edge computing introduced new security challenges because we have the heterogeneous devices on the edge environment. Also, in the last, we have the automated secure tools improve the patching management, vulnerability scanning, and the compliance reporting, reducing these manual errors and ensuring faster instance response. Okay, so we have done the lecture. Let's us recall what we have done and summarize the lecture. First, we briefly introduced the cloud computing and development models like the public, private, and hybrid clouds. And then we analyzed the attack factors and solutions in the SaaS, SaaS, PaaS, or infrastructure as a service. And then we talk about the best practices in the cloud security, like these responsibility models, regulatory compliance, IAM, and the encryptions, and also talk about the threat detection and incident responses. We also do a review about for a real-world cloud security breach, okay, the Capital One in 2019, and then we explore the future trend in cloud security. That's all. Thank you.